Assalamualaikum warahmatullahi wabarakatuh. We are from Group D. We are doing project about tourist attractions hotspot in Bandar Hilir, Melaka. And our group consists 4 members. Bandar Hilir, Melaka is one of the Malaysia's major tourism areas that it is part of the UNESCO World Heritage Site. It contains many historical and cultural attractions that attract both local and international tourists. Due to its popularity, tourist activities are concentrated in certain areas, causing overcrowding and traffic congestion. Therefore, this project used GIS to analyze the spatial distribution of tourist attractions to support better tourism planning.
Greetings, madam. We have 3 primary objectives to understand tourism in Bandar Hilir. First, our goal was to map and visualize the spatial distribution of tourist attractions. We needed to move beyond a simple list and see where these sites are located in relation to one another. Second, we aim to identify tourist attraction hotspot areas. By using specific spatial analysis techniques, we wanted to pinpoint where tourism activity is most intense. Third, we want to analyze the concentration of this attraction. To do this, we utilize tools such as buffer, resolve, and clustering analysis to understand the density and service coverage of the heritage zones.
So data source, the data used in this project were collected from multiple sources, which is Google Maps, OpenStreetMap, administrative boundary data, and QGIS software. So for Google Map, tourist attraction locations in Bandar Hilir were identified based on points of interest such as museums, historical landmarks, and cultural sites. The next one is OpenStreetMap. That data were used as the base map to provide contextual information such as roads, building, and land use for visualization purposes. Administrative boundary data for Melaka Tengah were obtained from the GADM dataset and used to define the study area boundary. QGIS was used for data processing, spatial analysis, and map visualization. So for methodology, the project followed a structured GIS workflow consisting of data preparation, processing, analysis, and visualization. For step 1, data preparation, all datasets were imported to QGIS. Coordinate reference systems (CRS) were standardized by converting the data to a projected coordinate system to ensure accurate distance-based analysis. Attribute data was checked and cleaned to remove duplicate or irrelevant records. Step 2, study area delimitation. The Melaka Tengah administrative boundary was extracted from the National Administrative Dataset. Tourist attraction point data were clipped using the Melaka Tengah boundary to focus the analysis only on the Bandar Hilir study area. Step 3, spatial analysis. Several GIS spatial analysis tools were applied. The first one is clip tool, used to extract tourist attraction points located only within the Melaka Tengah boundary. The second one is buffer analysis. A 300-meter buffer was applied around each tourist attraction to represent walkable influence zones and tourist accessibility. The third one is dissolve analysis. Overlapping buffer zones were dissolved to identify areas where multiple tourist attractions are clustered together. The last one is hotspot analysis. Hotspot analysis was performed using DBScan, clustering to identify spatial concentrations of tourist attractions. In addition, heat map symbology was applied to visually represent attraction density within Bandar Hilir.
Next, results and visualization. First, tourist attractions distribution map. So at the left picture shows that the spatial distribution of tourist attractions in Bandar Hilir, Melaka. So the tourist attractions locations were collected from Google Map and export SKML file and displayed as point features on the map. So each point represents tourist attractions in the study area. From this map, we can clearly see how tourist attractions are distributed and where they are more concentrated. Then on the right picture shows the tourist attractions locations after KML. Data were imported into QGIS and convert into S3 shapefile. So the tourist attractions are displayed as point features on an OpenStreetMap as a base map. So by convert the data into shapefile format, we are able to perform spatial analysis within the Bandar Hilir study area, such as buffering, dissolve, and clip, and also hotspot analysis. Next, this picture shows the clip, buffer, and dissolve analysis of the tourist attractions in Bandar Hilir Melaka. So first, the clip was used with the Melaka Tengah boundary to extract tourist attractions point within the study area. Next, a 300-meter buffer was generated around each tourist attractions to present walkable distance and accessibility. Finally, overlapping buffer areas were dissolved to identify zones where tourist attractions are closely concentrated. So these areas indicate locations with higher tourism activity and potential overcrowding.
Results in visualization, hotspot heat map, analysis map. So this map shows the hotspot or heat map analysis of tourist attractions in Bandar Hilir, Melaka. The purpose of this map is to identify areas with a high concentration of tourist attractions based on a spatial clustering. The hotspot analysis was generated using tourist attraction point data that were previously clipped to the Bandar Hilir study area. A clustering technique was applied to identify areas where tourist attractions are located close to each other. Heat map symbology was then used to visually represent to the density of these attractions. The color intensity of the map represents the density of tourist attractions. Areas shown in red indicate a high concentration of tourist attractions, while lighter colors represent lower density areas, like light yellow color. So, from the map, a clear hotspot can be observed in the central area of Bandar Hilir, Melaka. This indicates that most tourist attractions are clustered around key heritage and cultural landmarks such as museums and historical sites. This concentration suggests that the area experiences intense tourism activity, which may lead to issues such as overcrowding, traffic congestion, and pressure on local infrastructure. Therefore, this hotspot highlights areas that require effective crowd management and better tourism planning. Overall, this map demonstrates how GIS hotspot analysis can transform raw location data into meaningful insights that support tourism planning and sustainable development.
Moving on to our discussion, this project demonstrates that GIS plays a crucial role in supporting decision-making by clearly visualizing spatial patterns. First, they can implement crowd management strategies in the high-density areas we identify. Knowing where the hotspots allows for better resource allocation. Second, the data supports the need to improve pedestrian and transportation infrastructure. The buffer analysis highlights where walking zones are most critical. Third, we can use this data to promote lesser-known attraction. By seeing the cluster, planners can direct visitors to outlying areas to balance the distribution. Finally, these insights support sustainable tourism development. Protecting our heritage zones require understanding the pressure points, and GIS provides the data to do that. This project shows how GIS transforms raw spatial data into meaningful insights that benefit both the planners and the local community.
In conclusion, this project successfully demonstrated the application of Geographic Information System or GIS in analyzing tourist attraction hotspots in Bandar Hilir, Melaka. By using QGIS and spatial analysis tools such as clipping, buffering, dissolving, and hotspot analysis, The spatial distribution and concentration of tourist attractions were clearly identified. The findings highlight that GIS is an effective decision support tool for tourism planning, infrastructure management, and sustainable development. So lastly, for recommendations, based on the findings of this study, several recommendations can be proposed. The first, future studies should integrate visitor statistics or temporal data to better analyze peak tourism periods. Second, public transportation and accessibility analysis should be included to improve tourism movement and infrastructure planning. And lastly, this study can be expanded to other tourism zones in Melaka to allow comparison and support more comprehensive tourism planning. That's all. Thank you.